Here's a sequence problem that at a glance looks a little bit tough. On the number line above, the marks are equally spaced. How many marks would there be on this number line between the marks at 11 and 22? That means we don't count 11 or 22. We want the number of marks between them. Well, let's look at what we're dealing with. From the 0, let's say that's 11. We'd have 1 at 1/4, 1 at 1/2, 1 at 3/4, and then another mark at 1. Well, that series of 4 marks would continue until we get to 22. Because you see, that mark at 1, remember, is in effect that same mark at 0 in the next sequence. So we have 4 marks, and between 11 and 22, 11 from 22 leaves 11. So 4 times 11 gives us 44. But we have to subtract the 1 out that represents 22. So we have 43 marks between 11 and 22. Now, this is a sequence problem, and the key to this is to find a pattern that will repeat. Then you're going to apply that repeating pattern to the number of terms that we're looking for in the sequence. And the key to this is always, the tip-off is always going to be, they're looking for some number that's way on down the line, like 42, 54, something like that. So that tells you there has to be a repeating pattern. In this case, the first 4 terms of a sequence are shown above. After the second term, each term can be obtained by dividing from the previous term the term before that. For example, the third term can be obtained by dividing the second term by the first term. What is the sum of the first 42 terms of the sequence? We haven't yet established a repeating pattern, so we have to find it. Well, let's continue the sequence. 1/2 divided by 1 is 1/2. So 1/2 is the next term in our sequence. Then 1/2 divided by 1/2 is 1. Therefore, 1 is the next term in our sequence. Then 1 divided by 1/2 is 2. 2 divided by 1 is 2. So the next term is our 2. Then we have 2 divided by 2 is 1. So we can see we've established our pattern. Our pattern is 1, 2, 2, 1, 1/2, and 1/2. Then the pattern starts repeating. Okay, we want the sum of the first 42 terms of the sequence. So let's see what this sequence adds up to. 1 plus 2 plus 2 plus 1 plus 1/2 plus 1/2 equals 7. Okay, we've got this sequence, and the sequence has how many different numbers in it? Well, it's got 1, 2, 2. It's got 6. So we want to know how many 6's there are in 42. Well, there are 7. So we multiply 7 times 7 and find that the sum for these first 42 terms in the sequence would be 49. This sequence problem looks a little bit tough. There's one key thing to remember. We'll get to that in just a second. The first term of the sequence is -6, and every term after the first is 5 more than the term immediately preceding it. What is the value of the 100th term? The key to this is you've got to remember that you're adding 5 to each of the terms, but you can't count the first term twice. So when we set this up, we've got the first term, and then we've got 5 times the number of terms we're looking for, which would be n, less the first term. That's where we have to subtract the 1 out. So substituting the numbers in, -6 plus 5 times 100 minus 1, which is -6 plus 5 times 99, -6 plus 495 gives us 489. The key to this type of sequence is to remember you've got to factor that first 1 out. So your equation is going to be the first term plus the number that you're adding times n minus 1, n being the total number of terms you're looking for.